Hi, this is Michael Wu. I'm the Chief AI Strategist at Pros. Today I'm going to talk to you about understanding AI, its market landscape, and its business impact. So without further ado, let's begin. So first, I would just like to say that most of our understanding of AI has been coming from, I would say, the entertainment industry. I'm sure all of you have seen movies of Star Trek or Ex Machina, where you see robots with AI. They essentially, these beings that are super intelligent, they work really, really fast, they work all the time, and they always learn, always getting smarter every day. And we're not there yet, okay? But most of you who are in the business of AI probably have seen this diagram before. That essentially says that deep learning is essentially a kind of machine learning, and machine learning is a kind of AI. So this diagram is highly popular. It's actually in, I would say, in Wikipedia, so it's got to be correct, right? So, but unfortunately, this is actually not quite correct, okay? This image is even though it's highly popular, it's not quite accurate, okay? So, and the reason is because, deep learning is in fact a kind of machine learning. And however, machine learning is actually not a kind of AI, okay? So the reason that a person who created this image will put machine learning inside AI is because AI essentially uses machine learning, and machine learning is essentially part of AI. So therefore, you can kind of see why we will put machine learning inside AI, because machine learning is part of it, right? So this is actually the correct interpretation of this image. Okay, you should interpret it as machine learning as part of AI, and deep learning is a kind of machine learning. Okay, now the one reason that this is actually very misleading is because, let me just give you another example to illustrate this. Okay, V8, we know that it's a kind of engine. Okay, and engine is actually a part of every car, right? Now, when you actually take away these boundary definitions, right? It's very easy to misinterpret this diagram as V8 is a kind of engine and engine is a kind of car, which you know is incorrect, right? In order to understand AI, we really have to understand where AI really come from, okay? And to illustrate this, I think the best way is to illustrate a little history of business analytics. And that history is really, really simple, okay? It really starts out with data, and when you get lots of data, people really would basically compute statistics to summarize it, right? You see these trends and different indicators, different indices, and all these are what we call descriptive analytics, okay? And descriptive analytics is good, but it summarizes your data, so you don't have to look at every single data point, but you can only do so much, right? But once you do descriptive analytics for a while, you start to see, well, maybe I could start to see some kind of pattern. And once you see a pattern, you can say, well, now I can actually start to build a model, right? Once you have a model, the advantage of having a model is that now you can actually extrapolate to regions where you have no data yet. So what that means is that you can actually, in the temporal domain, the time domain, is that you can actually extrapolate to future, right? And then what you're doing is what we call predictive analytics, okay? Now, predictive analytics is obviously very, very helpful, right? But what is the real advantage of having predictive analytics? The advantage of having a predictive analytic is that you can now actually be able to see the future, what the future might be, right? Having this capability means that now you can actually start to tell people what to do, right? You could say that if you want to make money, right, you should actually buy right now at this point and sell at this point, right? This is when you actually move into what we call prescriptive analytics. But I would say that this is actually a really, really highly simplified history of business analytics. It goes from descriptive to predictive to prescriptive. Okay? The question is, what comes next, right? What comes next is really artificial intelligence, because artificial intelligence is really just the automation of decision and proper execution of subsequent actions. In picture, really, going from data to decision to action. Traditionally, that's always been a human's work, right? We decide what to do, regardless of what the data show us, whether it's descriptive analytics that shows me how your stock is going to perform, or you use a predictive analytics to show me the trend, the future trends of certain stock or certain market, right? Or if you even use prescriptive analytics to tell me that you should actually buy this stock or sell this stock tomorrow. We decide what to do, right? We humans decide what actions to take, right? So, so that's always been a human's job. But if you now start to automate these actions and decisions, okay? For example, if your data is driving decisions and driving action directly, okay, then you have basically the inception of AI. This is the beginning of AI. It's not really quite AI yet, but it's really the beginning of it, okay? And some examples of these already exist today, right? For example, you have algorithmic trading, right? Why tell me what to buy and when to buy? Why not just buy for me, right? Buy for on my behalf, right? That's algorithmic trading. It's actually trading for you on your behalf, automate those decisions and actions for you, right? Same thing as in automated loan origination, right? Why do you need a person to check off all these boxes in order to give you a loan, right? There's really no need to do that, right? Once person actually meet all the requirements, you should just give them the loan, right? Now, if we go back to the example in geospatial domain, right? You have the GPS that can actually tell you what to do in order to go home, right? GPS is actually a very common prescriptive analytic that we use every day, because the GPS will prescribe you a sequence of action to get home, right? But why do that? Why not just take me home directly, right? So you can see that this is actually the beginning of AI, right? So really, these tasks looked like impossible before, right? But it really is opportunity, right? What can turn opportunity, a challenge into opportunity, is that you have to do two things. You really have to change your mindset to recognize that really nothing is impossible, right? You may say, some people may say that from my experience, this has failed before, right? But sometimes your previous failure is because you don't have the right technology. So you really should leverage new technology, right? Okay, so now with this understanding, I think we can actually define what AI is now, okay? So now, before I actually define AI, I would like to just have a little bit of a disclaimer. Now, disclaimer is that, the definition of AI actually changes over time, okay? So it's actually very hard to define AI, right? And some people said that AI is what machine can do now that they couldn't do previously. And there's actually some truth to that, obviously, when optical character recognition came out, OCR, people think that was AI because now machine can actually read print. Not only can it read print, it can actually read handwriting. Not only my handwriting, but also yours and his and hers, everybody's handwriting. So it's really, really cool. People think that's artificial intelligence, but today your phone could do this, right? And nobody thinks that's actually AI anymore, right? So now, so you should take this definition of AI with a little bit of grain of salt, okay? But at this point in time, this time of our history of technology, right, the way I like to look at AI is really that it's really a machine mimicry of human behavior with two very important characteristics. One is automation, which you have seen already, right? It's the beginning of AI, the inception of AI is the ability to automate decisions and action, right? So automation is simply the ability to automate decision and subsequent actions, right? So that's one very important characteristic. The other very important criteria is that it actually has to have the ability to learn, okay? It has to have this learning capability. Essentially, the ability to improve its performance with usage. The more you use it, the better it gets at what it's actually doing, okay? So with these two capability, then you actually can have AI, okay? So AI is really just a machine mimicry of human behavior with the ability to automate and learn, okay? Now, now you know that, machine learning is really not AI, okay? As I said before, just because you have a model built with machine learning, with deep learning, it actually doesn't mean that you have an AI, okay? So now the real question is that, what makes AI smart? What makes AI truly intelligent, right? So this actually, starts with data, right? So big data get turned into a model, and data scientists do this. This is our job, right? What we use to do this is a very powerful tool called machine learning, right? Machine learning is the tool that data scientists use to turn data, hopefully big data, into a model, okay? Now, machine learning is really both a noun and also a verb, okay? As a noun, it's really just a bunch of algorithms that data scientists use. I could fill up more, several screens of names that would just confuse you, but I won't do that. But keep in mind that deep learning is in fact a kind of machine learning. Right? It's a type of machine learning that data scientists use, right? But as a verb, machine learning, it's really just a process of turning data into a model. So once you have a model, basically, if you feed it with new data, you're going to generate new results, right? And these results typically have to be interpreted by humans and decide what actions to take, okay? And typically these actions will have some consequences, some outcomes, and that need to be feedback into your analytic system in order for the system to work well, okay? So now, as I mentioned previously, that decisions are always humans' job, right? Regardless of what the analytic result may suggest, humans look at those results and decide what to do, right? And that's traditionally been the case. With actions, I would say that today, in a lot of the digital world, digital space, a lot of this action can already be automated with machine. And that's simply because the fact that in the digital world, it's really, really easy to automate because all it takes is to execute some code, right? And then you basically automate it in the digital world, right? In the physical world, a lot of these actions still need to be taken by human because robotic hasn't actually been advanced that quickly yet. But in the future, this all will be changing very quickly. So now feedback traditionally is also collected by human as well, right? And traditionally, we basically use a survey to collect feedback. And obviously, this is very, very slow. It's not going to work really, not going to work really well, right? And for this system to work well, this feedback actually need to happen in near real time, right? And so first thing that we have to do is we need to start tracking this feedback in an automated fashion, right? And this can be done in the digital world very, very easily because some engineers just have to write code to instrument that, to actually track that. But even in the physical world today, with the advent of IoT and these sensors and different devices, we can actually start to track real world feedback fairly easily, okay? So this is so tracking feedback in an automated fashion can be made feasible today, right? But today, I would say that if the model is good enough, right, then we can actually automate this decision as well. Okay, this decision here, traditionally carried out by human, that can also be automated, right? Why do you think that's the case? I guess the real question is that what makes the model good enough? Right? The real question is that if it's good enough, it can automate the human's decision, right? But what makes a model good enough? Right? The model is actually good enough when it matches a human expert's decision pretty much all the time. That's when it's actually good enough. Okay? So if a model's output does not match a human expert's decision, right, pretty much all the time, then the model can improve, right? Because the expert can actually train it more to improve its outcome, its result, right? But if the model matches a human's decisions pretty much all the time, right? Nothing is perfectly 100% in statistic ever, but when it's pretty much all the time, right? Then you can automate this decision, right? Now, how good is good enough? That depends on what industry you're in, right? If you're in the medical industry, then you better match a human expert's decision 99.999% of the time, right? But if it's in marketing, maybe matching the human expert's decision 80% would be pretty good, right? So this criteria is actually dependent on how good is good enough, actually depends on industry. But the real important thing that for you to recognize is that it's good enough when it's matching a human expert's decision all the time. Why do you think that allows us to automate it? Because if it's matching a human's decision pretty much all the time, what are you going to do when you actually make the decision? Pretty much all the time you'll be saying, yes, I agree, 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 right? So that's no need to repeat this. Why is it necessary to repeat this, right? If it's matching your decision pretty much all the time, you should just automate it, right? And once you automate this, that doesn't mean that you can't override it, right? When you disagree with a machine, right, you can still override. That's why the little bit of sliver yellow is still there, right in the corner, right there. Okay, so now when you automate this, when you can, as you can see in this picture, right, once almost all of this thing, these feedback loop here is completely automated already, right? Except in the rare cases when humans disagree with the machine, right? That's the only time when you can override it, right? But all the other time, it should basically run smoothly in a completely automated fashion, right? And there's actually two implications of this. The first implication is that, well, this feedback loop can go really, really fast because it has virtually no human involvement, right? Except in the rare cases when humans disagree with the machine, right? And the second implication is that, well, because everything is actually automated, right? Everything can be digitized and tracked and become data, right? Once everything becomes data, that means you can actually feed this data back into your big data, right? Back into your big data. And then you can actually go through this machine learning process again. And now you have a way to update your model, right? Your model now have seen more data, right? What do you think this model is going to do? This model is going to be better than the previous model that you had, right? And the result that it suggests will be better than before, right? So every time you use a system, right, basically you can actually have a way to improve your model with every usage, right? Now you could do this completely automated, right? But typically that's actually not a good idea. You want to do this in a semi-automated, so you have some human oversight because machine can actually learn things wrong, and that's usually not a very good idea. Okay, so now when you actually get this machine to be used over and over again, right? Basically, this model gets better and better. It gets better and better at predicting this process of going from decision to actions to outcome, right? The process of improving this model is what we call the learning loop, right? The learning loop is actually what makes AI smart, okay? Because every time you use it, the model gets better than it was before, okay? Now the power of this learning loop is really, really dramatic, right? I'm just going to illustrate this with a story that a lot of you probably have heard of already, right? And that is the story of AlphaGo beating the world champion in the game of Go, okay? So Lee Sedol is this Korean, Go champion in the world. He's the best guy in the world, right, in the entire world, by a huge margin compared to the next guy, who's to have AlphaGo, this machine written by human, right, who may not even play Go, right, to be able to beat this world champion is just amazing, right? So how do you think AlphaGo is able to do this, right? I mean, obviously, AlphaGo is written by programmers who are obviously not as good as he is, right? And the AlphaGo, the program, is trained with data who is actually not nearly as as good as this world champion is, right? So how do you think AlphaGo is able to beat this world champion, right? Think about this for a minute. The reason this AlphaGo is able to beat this world champion is basically through this speed argument, right? So basically, if you let AlphaGo play a human being, right? Typically, it would take you probably a few hours to play a game, right? Because that's typically how long you play a game of Go. But if AlphaGo is good enough, right, to play an actual human, then what can you do? You can actually let AlphaGo play against itself to engage in what we call self-play, right? So self-play, basically you can play against itself, means that now AlphaGo can actually play millions of games a day, right? Or you can actually play, I would say, hundreds of million games in a matter of weeks or a month, right? What does that mean? That means that AlphaGo can actually make all the mistake that a human could ever make in his entire lifetime, probably 2 or 3 lifetimes, and learn from those mistakes and never make those mistakes again, okay? Now that's the power of this learning loop, okay? Learning quickly and learning fast and not make those mistakes again is what makes you smart. It's what makes this AlphaGo able to beat the world champion in the game of Go. How can the formula be developed in an environment that's unknown, right? Basically, you use a formula that can learn and adapt, right? That's the best formula that you can have when you are actually operating in a world of unknown environment, right? Of uncertain data or anything, right? Basically, you can always learn and adapt, right? That's how you should think about these challenging problems in the future, okay? So a lot of companies often ask me now, what can AI do for me as a business, right? And I would answer that this is really just the wrong question to ask, because now you know that pretty much AI can do pretty much everything that human can do as long as you have the data to train it, right? So the real question that companies should ask is, what data can you digitize? And the key word here is fully digitize, okay? You have to be able to fully digitize the entire process. Then you will have the data to train the AI to mimic what humans do, right? Remember, AI is a machine mimicry of human behavior with the ability to automate and learn, right? So now you have the data, then to train the machine, then the machine will be able to mimic what humans do, right? Now, if you have a process, say a 10-step process, right, and you digitize 9 of the steps, right, don't expect AI to be able to fill in the last step. It won't be able to do that, okay? But if you digitize 9 of the process, certainly you can automate those 9, but you cannot actually, I would say, reasonably expect AI to be able to fill in the last step for you, because you have no data. Right? The data doesn't know what humans do, right? So the real question that business should ask is really, what can you digitize fully, right? So now, today we actually have a lot of AI in the market, right? Today we actually, I would say, have hundreds and thousands of AI applications in the market. And because we have so many different type of data, right? So, but there's actually 4 that's actually very, very important today, right? And I'm just going to go through them quickly for each type of these, right? Just to get yourself familiar with this. The first type is what we call perceptual AI, okay? So these are essentially, I would say, chatbots and digital assistants that you're all familiar with, right? And the biggest applications of these type of AI is in human-computer interaction, right? And there's really no surprise to this, because obviously, if you have a machine that could understand your language, understand human language, and could see the world as we do, can actually speak to you using your language, right? You don't have to write code, right? Then obviously human can interact with the machine a lot better, right? And sometimes these perceptual AI is also called cognitive AI or cognitive computing, because a lot of advance has been made to mimic these, I would say, higher cognitive functions of human, right? And such as image recognition, speech understanding, or speech synthesis. So these are actually used to be thought of as higher cognitive functions that only human can perform, right? But now with so much data that we can get around these, image data and also speech data, we can actually train the AI to mimic how we perform those tasks. Okay, so that's perceptual AI, cognitive AI. Okay. So second class is actually a class that's actually very common, very well known. It's called the internet AI. And obviously, because the internet has generated a lot of data from us surfing the internet, right? So the internet generates lots and lots of these data. And basically, these data can be fed into an algorithm, and then the AI can actually learn our preference and understand what we like or what we don't like, and then recommend product and music and so on for us, right? So examples of these are, I would say, Amazon's famous people who bought this also bought that, right? That recommender system, right? And Netflix and Spotify are also some of the early pioneers in this. The learning loop in this type of AI is very, very easy to understand, right? Based on what they recommend and what you actually choose to buy or to listen to, what movie do you actually watch, right? The AI actually learns your preference better, right? That actually updates a model and actually let it learn your preference, what you like and what you don't like, much better, right? So this is the biggest applications of internet AI is in personalization, right? Because once the machine actually understands what you like and what you don't like, you actually personalize your experience, right? So obviously, this type of AI is very familiar with a lot of users, right? And because the biggest application is in personalization, so sometimes this class of internet AI is also called personalization AI. Okay. Now the third class of AI is called autonomous AI, right? Autonomous AI. Well, the biggest applications of autonomous AI today is essentially the self-driving car, right? The autonomous vehicle. And actually, I think that won't be the case forever. I think soon it will be driving robots or other autonomous device, right? Autonomous drone and connected machine, IoT, and all that stuff, right? Basically, these type of AI will be able to allow machines to talk to other machine or parts of machine to talk to other parts of machine so that they could resolve conflict and function autonomously. Okay, so that's autonomous AI, right? And the last class of AI is what we call business AI, right? Now, the biggest applications of business AI is in the automation of business decision. So basically, these are very, very, I would say, diverse because there's so many different applications in this as well, okay? So business AI can be used in fraud detection, right? In algorithmic trading, And also in, for example, in machine-aided medical diagnosis, right? So typically, a doctor will look at your data, your prognosis to decide what disease you may have, right? So if you have all these data, feed it to a machine, right? The machine can actually mimic what a doctors actually do, right? So the decisions that doctors make, right? So these are, I would say, machine mimicking human in a particular domain, right? Because there's so many different applications in different domains, there's actually, I would say a lot of different kinds of business AI out there, okay? So Pros is also one of these business AI as well, right? So obviously we automate lots of business decisions around pricing and selling, okay? So what prospects you should go after, right? At what price you should sell this product to get the most optimal conversion rate, right? So all that are decisions that somebody have to make, but if you actually let AI learn let the data have access to these experts' decision, data around their decision, then the AI will be able to mimic that. Okay, so that's the 4 classes of AI, right? Now, what can these AI actually do for your business, right? So I basically boil down from hundreds and thousands of AI applications down to these 4, okay? But keep in mind that every single AI application out there can actually do something for your business, right? They exist for a reason. But there's actually, I would say, 3 very important business outcomes that these 4 and also many other AI can drive. The first one is actually to improve your customer experience, right? And the second one is to increase your business efficiency. And the third one is actually to help you grow your revenue, right? Now, to pick the right AI that's right for your business problem, it really comes down to what are you trying to achieve? What are you trying to accomplish, right? Now, this really comes down to these 3 categories of outcome that you can drive, right? So if your goal is to improve customer experience, right? For example, you want to deepen engagement, you want to boost conversion, you want to drive loyalty gain from your customers, right? Which type of AI do you think you should use, right? Given what you understand right now, you could probably answer this already, right? It's obviously going to be the perceptual AI, right? Because obviously the perceptual AI can improve human-machine interactions, right? Then it can actually give you an improved customer experience, right? Obviously, personalization AI or internet AI can also do this because when machine actually understand what you like and what you don't like, it can actually give you a much better customer experience as well, right? And if your goal is to increase efficiency of your business, such as reducing costs or improving productivity or increase throughput, right? There's actually a lot of different AI that can actually help you. This is actually a very, very crowded space. A lot of AI out there, are created to make business process much, much more efficient out there, okay? So this is actually a pretty crowded space. Lots of startups in Silicon Valley actually develop AI to automate some kind of process to make them more efficient, okay? So obviously, in this case, perceptual AI can actually increase your efficiency by enabling people to work everywhere and anywhere, right? So if you have a digital assistant that can actually help you automate some simple process, such as replying to an email or fetching you some data, right? You can pretty much work anywhere. That improve productivity of each employee and therefore increase your efficiency of your business that way, right? And the second way to do this is obviously through autonomous AI. You can actually replace the human employee with a robot, right? And that can also improve your efficiency as well, to increase your efficiency as well, right? And also business decisions can be made much more efficiently with the help of business AI also, right? And lastly, if your goal is to grow revenue, to expand the top line, to drive margin improvement, to drive profitability, what type of AI would you use? Basically, there's only one type that you can use. Basically, that's business AI, right? Business actually grow revenue by making the right decision and better decision, right? So now that doesn't mean that perceptual AI or internet AI cannot drive revenue growth. They can, okay? In fact, every one of these type of AI, perceptual, internet business, and autonomous AI, they can all drive every one of these outcomes, right? Obviously, so for example, you could say that perceptual AI, right? If you give customer a good customer experience, the customer is going to love you. They're going to want to do business with you more, and therefore they will purchase more of your product, and therefore driving revenue growth, right? they can drive revenue growth, but it's not a direct action. It's not a direct consequence, right? So these big dots here in this picture really meant to illustrate where you had the most direct impact, right? Where AI had the most direct impact, all right? So with this, I just wanted to answer the last question, that where is technology taking us, right? Technology basically will allow business to do more with less. And that's what technology have always done for business. What's different with AI is that now you can automate decisions, right? So the humans don't have to be bogged down with mundane and repetitive tasks, right? Humans can actually do what they do best and what they love to do, okay? With that, thank you for your time and attention. You can also follow me on Twitter as well as LinkedIn.